of core further maths, some polar coordinates here. I've got the FP2 last question on the paper, 9 marker finish. So we've got a curve here, polar curve, and a straight line, which is unusual. So they give us the equation for the curve C, and the line L looks like this. It's really because if you got K sec, that's K times 1 over cos. So really, it's you can rearrange it to R cos equals K, and R cos, of course, is the X coordinate. So it's just a vertical straight line, X equals K. Anyway, so it says the intersect of the point P, the line and the curve, and it gives you the length of O to P. I'm going to determine what K is, and I'm going to find out what this area is. So here we go. To get the K first, well, we know this length from O to P is 1 plus root 3 over 2, but it's also the R, both of these. So if this angle here is the theta, the angle between OP and the initial line, and that OP is 1 plus cos theta. Like I say, that's equal to 1 plus root 3 over 2. And knock out the ones then. So I've got cos theta is root 3 over 2. And incidentally, that means the theta is pi over 6, but I don't need that just yet. I also know that the R, the OP, is K times sec theta, whatever that angle is, which is K over cos theta. I know that cos theta is root 3 over 2 from the C equation. So I've got K times root 3 over 2. Again, that's equal to 1 plus root 3 over 2. Told us that what the length of OP is. So the K is going to be 1 plus root 3 over 2 multiplied by root 3 over 2, which gives me root 3 over 2 plus 3/4. I say now I'm going to find the area of this. I'm going to find I'm going to break it into the two sections because I'm going to have to find this triangle. But I'm going to find this area first. This area sort of between C and the line OP. That angle there, like I say, is pi over 6, and I know the length of O to P was 1 plus root 3 over 2, and so I'm going to find this area first. And the required area looks like this. Remember, it's the half r squared d theta between my two limits, and the limits I'm sort of integrating between pi over 6 all the way around to pi, and then of course when theta is equal to pi, and that's minus 1, so it's 0. That's why it sort of goes back to O. So just when the theta gets to pi, the r becomes 0. So we're integrating between pi and pi over 6, 1 plus cos theta all squared. Now, standard thing I've got to do really, I'm going to square it out because I need to sort this cos squared out. I can integrate cos, I can integrate 1, but the cos squared, I use a double angle formula for cos 2 theta, which is cos 2 theta is 2 cos squared minus 1. And rearrange that to cos squared equals, I get this, and I can sort of simplify it with a half. So that's what I'm integrating. So I'm going to find out what this is, because I'm going to integrate the 3 over 2 and get 3 over 2 theta, integrate the 2 cos, get 2 sine theta, and integrate a half cos 2 theta. Well, that's going to be a quarter sine 2 theta. So that's what I differentiate to get this. I need to use my limits of pi and pi over 6, and then I'm going to halve it, of course, to get the area. So I'm going to work this out. I'm going to stick the limits in. Pi in first, minus, I'm going to put in pi over 6. A lot of simplifying to do here. I can't do anything with that, but sine of pi and sine of 2 pi, both 0. This, it turns out to be just pi over 4, because it's 3 pi over 12. Sine of pi over 6 is a half, so that just gives me 1. And I've got a quarter sine 2 lots of pi over 6, and sine pi over 3 is root 3 over 2, so that's going to be root 3 over 8. And if I sort of simplify that down, you can still do it on the calculator, but you've got to keep the pi bits and the rest of it separate, because your calculator will get everything confused. So I've got 5 pi over 4 for the pi bit, and then the rest of it is minus 1 minus root 3 over 8. Like I say, when I halve that to get the area, get this 5 pi over 8 minus a half minus root 3 over 16, and that's sort of the yellow area. I also need this area, which is a right angle triangle. Now to get it, well, the area of the triangle is half the base times the height. The base is the sort of the x value, which is r cos theta, so it's OP times the cos of pi over 6, sort of the adjacent side of a right angle triangle. So the hypotenuse times the cos of the angle, and then need the height as well, which is the y value, so OP times the sine of pi over 6. Now I'm going to do this. This is a funny way. I'm going to write it as OP squared, half times OP squared, and then I'm going to use a sort of version of the double angle formula. Sine 2 pi is 2 sine theta cos theta. So here I've got sine pi over 6 cos pi over 6. So that's the same as a half sine pi over 3. So I've used pi over 6, and then I've got pi over 3 here. Which means I've got a quarter, and then I need OP squared. So I'm going to square this. I get 2 lots of 1 times root 3 over 2, and then root 3 over 2 squared, which is 3/4, which is a root 3 plus 7/4. And then I need sine of pi over 3, which is root 3 over 2. And I'm on sort of a quarter times root 3 over 2, which is 3 over 8. On a quarter times 7 over 4 times root 3 over 2, which is 7 root 3 over 32. And then finally, we'll add the two together. So this one plus this, and then do all that one in the calculator. Don't put the 5 pi over 8 in there, but all this in the calculator. You get minus an eighth plus 5 root 3 over 32.